In Niederstetten, a small town in Germany's southwestern state of Baden-Württemberg, the distribution grid operator NETZlabor is researching innovative solutions for the power grid of the future. Working in collaboration with their project partner Siemens, the Network Laboratory Niederstetten is aimed primarily at optimally integrating renewable energy while ensuring that the electricity supply system remains highly reliable. Niederstetten, like everywhere in Germany, is home to a growing number of wind power and photovoltaic generating facilities. This rising volume of power grid feed-in from distributed sources is pushing the load limit of the existing distribution grid. Maintaining voltage stability is proving to be a particularly major challenge. An important goal for the grid operator is to make certain that the voltage level always remains within the allowable range so that the customer's electrical appliances function properly, while at the same time ensuring unrestricted feed-in of renewable energy is possible at all times. Due to the increasing number of distributed power plants, this task becomes more and more challenging. The traditional solution to this challenge would be to conventionally expand the grid with new cables and overhead lines. Such solutions, however, are expensive and entail extensive construction. The capacity of a grid expanded in this way would only be fully utilized on very few days in the year. In addition to addressing these new challenges arising from Germany's energy transition to a new energy mix, NETZlabor is also working continuously to improve the reliability of power supply to customers in rural areas. In our example, a tree has snapped and fallen onto an overhead line. The resulting fault is detected at the transformer station and the entire medium voltage section marked in blue is shut down for safety reasons. A NETZlabor technician must then drive along the line from one distribution substation to the next to find the exact location of the fault. Switchover operations in the grid enable the technician to isolate the fault location and establish power supply to the customers via alternative feed routes. The faulty line can then subsequently be repaired. Especially in the case of large networks like the one in Niederstetten, searching for and isolating fault locations can be a very time-intensive undertaking. NETZlabor is proactively helping to shape the energy transition and working to develop innovative operating equipment and concepts for meeting these challenges. These innovations include intelligent substations. In these substations, all important electrical parameters are measured and the data forwarded to NETZlabor's grid control center. The control center crew can operate the switches in such distribution substations by remote control. Within the local Niederstetten network, such intelligent substations are placed at 9 strategically important locations. In addition, measuring instrumentation has been installed at the ends of each medium voltage line where the highest and lowest voltage levels generally occur. With the help of the line voltage regulators, the voltage level in the downstream grid will be adjusted according to the given situation. This makes it possible to accommodate higher power feed-in to the existing grid from renewable energy sources without having to physically expand the grid. 2 medium voltage line regulators from Siemens have been installed in Niederstetten. These are the first units of their kind anywhere in Europe. The centerpiece of the project is the regional controller, likewise supplied by Siemens. This distributed grid intelligence communicates with all the mentioned components and intervenes in a control capacity when needed. The regional controller is located at the Niederstetten primary substation. While it functions autonomously, it can be monitored from the control center. All these components cleverly working together allows the challenges in Niederstetten to be met and mastered with innovative solutions. Thanks to the distributed measuring instrumentation, the regional controller in the primary substation recognizes situations in which high power feed-in occurs. If the voltage level rises too high, the controller transmits a command to the line voltage regulator to lower the voltage level. The controller steps the voltage down and the grid bottleneck is eliminated. In the event of an outage, the entire medium voltage line is still shut down like before. However, thanks to the information from the intelligent distribution substations, the controller can locate the fault with high precision. It calculates within a matter of seconds the optimum grid configuration for isolating the fault and quickly restoring supply to as many customers as possible. The switches in the various intelligent distribution substations are then regulated by the regional controller to establish the grid configuration previously calculated. Power failures can in this way be limited within a very short time to a very small section of the grid, which the Netze BV technicians can then target and repair. The project in Niederstetten clearly constitutes a comprehensive package which, thanks to clever voltage regulation, increases the grid's capacity for accommodating power feed-in from renewable energy sources. And thanks to a distributed grid automation system, it ensures that power supply to the customers is highly reliable. The knowledge gained from the Network Laboratory Niederstetten is being incorporated into future Netze BV projects, and this expertise is making a key contribution to successfully implementing the energy transition.